Hello, today we'll be working on LeetCode 94, Binary Tree Inorder Traversal. So for this problem, they want us to return the values from a binary tree in order inside of an array. So what they're primarily testing is if we know how to do inorder traversal. So inorder traversal is a way to move through a binary tree, and this kind of traversal is particularly useful for binary search trees because of how the values are stored in those types of trees. So using this traversal method, you can visit the nodes in order, hence the name, and this means we visit the nodes from least to greatest when it's used inside of a binary search tree. Okay? So we can break this style of traversal down into these steps. So we visit the left node, visit our current node, and then visit the right node. And if that doesn't make sense right away, don't worry about it. I created an animation to help us visualize this. So we started our root node. Red represents a node that we aren't finished with, and green is a node that we are finished with. So we will immediately go into the left node and continue moving down the left nodes until we hit null. So what we've just done is step 1. When we hit null, we return into our previous node, which is where we do step 2, which is visiting the current node. And don't think too much about the word visiting. What we mean by visiting is that we're now working with the node's value. So this step is where we push the node's value into the array that will be returned. So after that, we move on to step 3, which is visiting the node's right value, the right node. So we then continue these steps until we've visited every node, and then we return our array with all of our in-order values. So let's go ahead and step into the code, and we're going to do 2 examples of this, one being the recursive solution, and the other is going to be the iterative solution. So for the recursive solution, we're going to create a variable named result and assign it an array. We'll create a function named traverse, and it takes a node. So if the node is null, we'll return. This next section is where our in-order traversal happens. So first, we traverse the node's left. Then, once we've returned from the call, we push the node's value into the result array. And then lastly, we traverse the right side. So we call traverse and give it the root, and then we return the result. And then if we run this, cool. So next is the iterative version. So if we don't use recursion, we need to implement the call stack ourselves. So we'll create a result array like last time, and a variable named stack that's also assigned to an array. So then we'll also create a current node variable and assign it to root. So I'm creating this variable to make the code more readable for myself. So we'll be pushing and popping nodes from the stack, and this simulates our call stack. So we're going to use a while loop, and we'll keep looping as long as the stack's length is greater than 0, or our current node isn't null. So if our current node isn't null, we'll add the node to the stack and then move our current node pointer to the left. Else, if the current node is null, we'll pop off the last node from the stack and assign it to current node. We'll now push the current node's value into the result array and then move the current node pointer to the right. So once we reach the very last node, our condition will no longer be valid and the loop will break. Then we just return the result. Alright, so I hope you found this helpful. Please leave a comment below if you have any suggestions, and I'll catch you in the next video.